Shorter time, same distance, yes? So, again, but you're still going to go up with a stop, right? But you're going to cover the same amount of distance in way less time. Everybody with me? And how will the bus compare to the drive? It'll be longer, same distance. Will it be faster than walking? Depending on where you're taking it from, right? But you wouldn't get on the bus if you lived over by Godson, right? You'd walk, or you'd get around with your folks. Everybody with me? So it would be similar to, it would be between drive and bus. Everybody understand? The point I'm trying to make is that range doesn't change, does it? But the domain changes because you're covering the same amount of range in more or less domain. Everybody good? All right. Did anybody have any questions about page 154? I'm going, as always, to do a lesson before I give you back your cumulative and go over it. Ah, wait a minute. Yeah, okay, good. No, because part of that you can't do yet. Yeah. 154 is printed one page before where it should be printed. So everybody go to 155, which should say discrete and continuous data. Yes? All right. Okay. Okay, let's graph this. What would go on the x-axis? Read the question, decide what you would put on the x-axis. Yep. Right. Except remember, two things need to be written there. One, what we're measuring, which is time. And two, how we're measuring it in days. Is everybody happy? Great. What would go on the y-axis? Cost. And how is it measured? In dollars. Everybody good? All right, now let's put some info on our graph. $65 a day for the first 3 days. So I need 3 days on the bottom, correct? How far is this graph going to go?
7.
Up to 7. So 1, 2, 3, 4, 5, 6, 7. Everybody cool? All right. What's the first piece of information I have? If I rent the car for 1 day, how much am I paying? $65, yes? So we better go up here. Let's go up by tens, shall we? 10, 20, 30, 40. Actually, tens is really no good, isn't it?
Yeah,
We're going to be going up pretty high. Let's go up by 50s. 50, 100, 150, 200, and so on. Everybody happy? Sorry about that. Everybody happy with the scales? Yeah. Everybody understands why they're where they are? One's independent, one's dependent? Yeah. You and I right now are passing days, but we are not renting cars, so therefore we are not paying for cars. Okay, good. So the first dot, if I don't rent the car at all, do I pay any money? No. So at $65 here, should there be an open or a closed dot? Right, Emily, why? Yeah, open dot. Because I can't rent the car for 0 days, can I? Right? If I walk into the store and I say, hey man, I want to rent a car, and they don't give me the keys, do I give them any money? No. But as soon as they give me the keys, do I start paying? So Wong is the agent at the car rental place. I say, I want to rent a car. He says, sure. We shake hands. He hands me the key. Have I started paying? Yes. So right away, it starts, doesn't it? And how much do I pay for that first day? Does it ever change? So I go straight across to 1 day. And it must be a closed dot because up to 1 day I've paid $65. Is everybody happy? Yeah. All right. What happens if I want to have it a second day? I'm going to have to pay another $65, aren't I? Which would take me up to 130, agreed? So I go up to 130 now. Will this be an open or a closed dot? Open. Because I don't start paying 130 till when? Till the second day starts. Everyone agree? So what's this line going to look like out to day 2?
Go straight.
And it's going to be flat because I'm only paying 130 bucks. Everyone agree? Okay, what happens from day 2 to day 3? Same thing, except I've gone up to 195 now, right? Open dot, line, closed dot. Is everybody cool to there?
Yeah.
Now, does anything change for days 4, 5, and 6?
The price that it goes up by.
It only goes up by 30, but will the graph look any different? It'll still be an open dot, flat line. It'll just be going up by 30s. Everybody happy with that? So, it would look like this. Be up by 30, up by 30, up by 30. Oop, that needs to be an open dot. Make sure I've done enough lines here. Day 1, day 2, day 3, day 4, day 5. 6 and 7. Is everybody happy with that? Does everybody understand why we drew it this way? Oh, that's just because my drawing is bad. Now, I want to ask a couple of questions before we go on with this. First question, while we wait for my computer to stop to be working properly. Is this a function? Have I given you a tool to check if a graph is a function? What is that tool?
Vertical line.
The vertical line test, right? There's a vertical line, right?
But those are all open dots. So
Does that line ever hit it twice?
No.
Why? Because it's an open dot. So is it a function?
Yeah.
Excellent. Okay, so that's question 1 out of the way. Now, let's look at question 2. Should I join these points? What are my options for joining? Would it make sense to draw this line? Come on, you're such a piece of crap. Would it make sense to draw this line?
No.
Why? Because they're open dots. They don't exist, do they? So that, no sense. We can't connect those lines. All right. Would it make sense to connect this line? Can time ever stop? So should there ever be a vertical line on a time graph? So that line makes no sense. So just let me tidy this up again. Let's close this because it's really pissing me off today. So we agree we can't do the vertical lines, right? Okay, so what about this line? Does that one make sense? It does?
no,
Why not, Aiden?
because there are entire sections you're ignoring. You're not accounting for the entire
This graph tells me that at that input of a day and a half, 1.5, I would pay that much money. Is that true? No, because I pay for the whole day, don't I? So, even though I have an input all the way along, my domain is the same all the way along up to 7. Is my range?
Quick question. When you said it couldn't go up because obviously time can't stand still and all, but those open dots technically mean that it's point infinity 1 just ahead or whatever. So it's technically, though you can't see it, it would be a time passing when it goes up. It's just not technically. Okay, maybe that's phrased a little strange. The point is, the open dot means that technically, when you're putting from the closed dot up to the open dot, there is a small bit of time that is passing.
Which would mean it can't be a vertical line.
It's not a vertical line.
It would be a vertical line.
It would only look that way, since the open dot means that there's a point infinity and then a 1. That means that 1 at some point in infinity was a time that passed.
I don't start paying the next bill until the day passes. Right? So that vertical line, that point does not exist. Up to here I'm paying, and then I start paying here. This time cannot, there is no time that is instantly in both spots. We don't need to make this philosophical discussion. I'm telling you, you can't have a vertical line on a time graph because time never stops. So you cannot connect those two.
I was saying that it wasn't stopped, but that time had passed there.
Yes, but then how do you show that on a graph?
Okay, your point is that since it can't be shown in the graph, it
You don't do it. Okay. So, does everybody understand why we cannot connect the black dots with a line? Everybody? Because we're well aware that if we rent this car, we don't keep it for a day and then miraculously appear on the second day, do we? The domain goes all the way along. You can have the car for any amount of time, can't you? But your pay, how much you pay, does it go all the way up? No, because I can pay 65, 130, 195, and then it goes up by 30. I pay then 225, 255, 285, and 315, don't I? Do I ever pay any amount in between? No. So I cannot connect the line because even though I have an input, notice I have no outputs between these dots. Does everybody understand? So, should the points be connected? No. Why? Well, option 1, the open dots don't exist. So I can't do a line to the open dots, right? Number 2, the closed dots show impossible outputs if joined. Right? I can't possibly pay $87, can I? Because one day is 65. Once that second day starts, it's 130. I cannot pay any amount between 65 and 130. Does everyone understand? So even though I have an input, the output is the same. Is it a function? Yes. Why? Right. Every input gives a unique output. There is no way I can repeat outputs, can I? Soon as I change it from one day to the next, I get a new output.
Can I write my answer like that?
Yeah, sure. I don't care how you write it. Everybody good? Now it gets tricky. What is the domain and range? What's the domain? It's on the x-axis. What's the lowest amount of time I can rent a car? 0 days. I walk in, hey, I want to rent a car. It's going to cost me $65. I don't want to pay that much. I walk out the door. So it would be 0, but does it include 0?
No.
No, because there's no output at 0, is there? So what arrow do I write here? An equal then or a less than? Just the less than. And what am I measuring? It's on the x-axis, but it's got a title now. Days. And what's the maximum I can have the car for with these prices? 7. Can I have it for 7 days? So what arrow is it?
Equal.
Less than or equal. Everybody cool? And what's the other way I would write this? Round bracket.
0, 7, and square bracket.
Can everybody do that? Which part of it can everybody not do? Which part of this makes no sense? Because not everybody nodded. It's better than usual. Normally nobody does anything and I have no idea what's going on. But at least this time a couple of people were like, so I know that something's up. Please notice there's two things happening here. There's the concept, 0 to 7, and then there's how you write it down. Which is the problem? Is your problem the way we write it, or do you absolutely not understand that the days have to be 0 to 7? And now everybody's suddenly okay. The writing part is what's confusing. So everybody understands that this is 0 to 7. Right? Okay. So now all you have to do is think with math. We know it has to go 0 to 7, right? We know you cannot rent a car for 0 days. Right? Am I renting a car right now? Right, it's impossible. Once I rent the car, I have it for the day, don't I? So that's why 0 has to be the lowest number. Is everybody okay there? That's why we have this instead of equals. Is that all right? Okay. Can I keep the car for 7 days? Yes. So that's why this one is equal. Why is it written this way? Because 0 is less than the amount of days I can have. Right? Because I can't go lower than 0. So 0 is the lowest I can go. But my days are lower than 7 because I can't go past 7. Everybody good? All right. What's the range? Can I write the range with any arrows or brackets? No. Why? Because I'm stuck, aren't I? What's the first range I could have? 65. I heard somebody whisper it. What's the next one? 130. What's the next one? 195. That's the first 3 days, right? Then I start getting a deal, don't I? What's the next day going to be? No. 225, because it's only $30 after that, isn't it? And then what's the next one? 255, that's 5 days. Then what? 285, that's 6 days. And 7th day? 315. And I can't use these because my range is it's in steps. It's not a part of the axis. Does everybody understand that? Aiden.
And you can't put a 0 because it once a single digit, you can start as an add.
That's my next question. Thanks, Peyton. Why was there no 0? Because there is no input of 0. Because we never equaled 0. Do you understand? Is everybody good? Okay, that's the concept. Now you're all well aware that every concept in math gets a name, yes? These are the names. Discrete and continuous data. Discrete data means that the IV and DV are not intervals. Okay? Intervals. There we go. You do not have every number available to use as an input and output. Now, right now, this doesn't make a lot of sense, but it's about to. Trust me. So, if discrete data means you do not have intervals and you do not have every number available, what then is continuous data? I'm just getting to that. You do have every number available for input and output. And Aiden has just given me away what's going on the very bottom of the page. There's a graph, yes? It's a function, yes? The domain goes all the way out to here. Agreed? At every x value, there's a spot on the line, yes? So the domain is an interval, right? Now, check the range. Is there a y value all the way up to here? Yes. So this is continuous data. The line is solid. Now, over here, and I shouldn't use blue and red because I've been doing my domains and range in blue and red. Here is what we just did. Okay? I am eating or drinking. I'm eating potato chips. Okay? I'm using Pringles. So they're all nicely solid all the way down until the very, very bottom where they're crumbly, right? But for the first 100 chips, it's one chip, right? So I take out the chip, I put it in my mouth. Right? Takes me, Aiden says 3 seconds, right? So time is down here. Chips are here. Takes me 3 seconds to eat a chip, yes? So one chip in 3 seconds. Agreed? The next thing in that tube is another solid chip, yes? I can't take out a half a chip, can I? Right? So that the next dot is going to be at a second chip. And now I'm at 6 seconds. Everyone agree? Notice there is no output between the two. Everybody understand? Everybody good? All right, let's apply it to a couple of real life situations. Turn the page over and let's talk. We're going to do two things here. One, we're going to do IV and dV. At a constant pressure, the speed of sound is related to the air temperature. Which of those is independent?
Air, no. Yes, because the speed of sound is the speed of the this is weird for me. It's related. No, somebody else.
I have 2 votes for air temperature being the independent variable. Do I have any dissenting opinions? Are we all sharing an air temperature right now?
Yeah.
Excellent. Now, nobody say a word, nobody move. I know it was a complicated instruction, Maria. Nobody say anything, nobody move. Are we sharing air temperature? Are we sharing a speed of sound? No, because nobody's talking. Does everybody get it? So what's the IV? Air temperature. What's the dV? The speed. Everybody cool? Everybody understand? All right, now let's make a pretend graph. We don't know what is happening here, do we? We don't know if the temperature speeds sound up or slows it down. We don't know that. But we know they're related, correct? Everyone agree? So let's put some temperatures down here because the temperatures are independent variable, yes? So let's start with -10, 0, and +10, yes? Is everybody happy with that? Everyone agree? All right, which means the speed of sound is here. Right? So it says speed, quite obviously. Aiden, Fonseca, you come up and try to draw on this thing. I've seen your drawing on this thing. It's crap. It's hurtful.
I can remember, it's just when the second O merges into the D.
First of all, there's no O's. They're both small E's. At any rate, we don't know what happens, but we take some measurements. Okay? So we find that the speed of sound is, let's call it 400 kilometers an hour. Who cares? We take a measurement and we find it -10. It's there. Agreed? Everyone agree? Okay. And then we find as we get warmer, the next speed of sound was 500. That's our next piece of data. Everybody cool? So I went up to 0 and the speed of sound was now 500. Now, what would you expect it to be at 10?
600?
600. I don't know if this is right. I'm just using this as an example. Everybody with me? Now, I only have data at 3 points, don't I? But can temperature go from -10 to 0 without going through 987654321? Can temperature change from -10 to 0 without going through -9, -8? It can't, can it? Does everybody understand? So there has to be a line Because these temperatures exist, don't they? So we can draw the line because this is continuous data. Does everybody understand? You cannot continue, I gotta learn to spell, continuous. You cannot have a temperature change. I'll give you another example. You put a glass of water in the fridge. That water came out of your tap at 10 degrees. Does it turn to ice right away? No. It has to go through all those temperatures to get down to 0. Understand? Everybody with me? Okay, let's go to the next one. What is your IV and your DV? Say it to yourself quietly or your neighbor. Don't yell it out for a moment. Let everybody have a chance. Who would like to volunteer an answer? Aiden.
Age and years is the variable, and the daily dose is the time variable.
Does everyone agree? Why, Aiden? Because you're right.
Because whether or not you take the medicines or even have to, you're still going to be that age.
You have an age. Right? Okay, now, so let's put it on a graph. What's going to be down here? Age. Measured in what? Years. Agreed? Yeah. So, since it's woman, let's start at 20. Everyone happy with that? Then it's got to go up in what? We're going up by years. So, the next one would be 21, 22. Agreed? Yeah. And dosage is here. So let's call the dosage 100 milligrams at 20. When does it change? When she reaches what age? 21, because we're measuring in years, yes? So at 21, it goes up to 150. What happens in the middle here? Does she add 1/365th of a milligram every day? No. So would we connect this line? No. Because there's no input except 20 and 21. Does everybody understand? So this is discrete. Is everybody with me? Everybody's with me? Okay. Let's go to number 3, because there is a third one, isn't there? Yeah. There's 4, I think. My computer's stuck, so I don't know. What's next? You guys start sorting it out. Cans of juice related to the cost. IV, DV. We've already talked about this one. We haven't actually, and it was a question on a textbook page. But back then we were only talking domain and range. Now we're talking about discrete and continuous. So what is it? What's the IV? The independent variable is cost? Cans. Because if I buy no cans, I don't pay for no cans. Right? So graph it. What's on the x-axis? Cans. What's on the y-axis? Cost. What's the lowest amount of cans I can buy? 0. And then what's the next amount of cans I can buy? 1. 2. 3. Each can costs 75 cents. If I buy 1 can, how much do I pay? 75 cents. If I buy 2 cans, how much do I pay? $1.50, right? Can I connect that line? Why? I can't buy half a can. I cannot go into Safeway and say, I'd like a can of Five Alive, please. Glug, 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 glug. I'm done here. Can I have 37 cents back? Can you? No. You've bought that can. So there are no inputs between 1 and 2, which means there are no outputs between 75 and 150. Does everybody understand? If there's no inputs in here, then my range or my domain can only be the dots, can't it? It can't be an interval. If it can't be an interval, is it discrete or continuous? Discrete.
You also can't have a half.
So that should give you a little shortcut. If you can't have fractions on your domain or range, can you possibly have continuous data? No. Everybody with me? And the last one. Altitude is related to temperature. We've also talked about this one. What's the IV? What's the DV?
Well, temperature is also related to the time of day and season, though. That's why I think.
No, it's always related to altitude, and it's always related to time of day, and it's always related to season. But you cannot compare 3 things on one graph. This graph, you can only compare 2 things on a graph. This graph is comparing altitude and temperature. Which one is independent?
In this instance, at least
Let me tell you.
it's
Look out the window at the giant mountain south of us. What's on the top of it? Snow, right? What's different between us and there? Altitude. Do we have an altitude?
Yes.
Do they have an altitude? Excellent. Why is there no snow down here? Because temperature depends on altitude. So my independent variable is altitude, and my dependent variable is temperature. Agreed? Okay, let's graph it. Altitude here. What would we measure altitude in? In Canada. Meters. What do we measure temperature in? Degrees. Nice. Is in degrees. Right? Degrees Celsius. Yeah? Right now we're on the ground, aren't we? We're pretty darn close to sea level, right? So we have an altitude of 0, and the temperature outside right now is what? Does anyone know?
690.
Check our phones. Everybody grabs their phone. It's 12 degrees. Everybody happy? So at 0, we're at 12. Everybody cool? Altitude is 0 meters. Now let's check. Mount Baker temperature. -5. Right? So we got to change our graph, don't we? Well, no, we don't. We can go like this. Right now, we're at 12 at 0, correct? Right? As my altitude increases, what happens to my temperature? Decreases. So, wait a minute. As my altitude increases, it's got to go like that, doesn't it? Right? So, here I am at -5, and my altitude has gone from 0 up to whatever. Everybody understand? Now, can I miraculously go from 0 altitude to the top of Mount Baker without passing through all the other altitudes? No. Can the temperature jump immediately from -5 to 12 without passing through -4, -3, -2, -1? Can it? So it is continuous. Yes, if it was Star Trek, yes. But it isn't. So stop. Don't confuse the issue. Everybody understand? Everyone is good with discrete and continuous? Good. Now, go back to page 154 and do that page. Let's say you work for 10 minutes till 10:32, then I give out the cumulative and we go over it. Okay? What's the next thing on your outline? Quiz. When will that be? Can't be today. It'll be Monday or Tuesday. It's a quiz. It doesn't count for marks. We'll probably do it Monday. After we've woken our brains up and done a couple of warm-up questions and things. Pardon me? Yeah. Everything up to and including discrete and continuous data. Everybody good?
Hi, is Calvin Hunter your peer tutor?
He used to be.
He's kind of useless as a peer tutor.
No, he was the greatest peer tutor I ever had. But
No.
yes.
Oh,
But he was falling behind in a couple of other courses.
okay.
And I told Sagert to leave him in here on that. So if he gets caught up, he could come back to me. I didn't want to lose him for good. But, yeah, I don't know if...
There he hangs out. Okay.
Yeah.
I'll look for him another one.
I'm sorry? Yeah, age counts as time passing.
Where's the quiz of us?
Excellent. You have a quiz, which that one was at a 12?
Yeah.
11, and that was in the polynomial unit. Yep. Okay. Yes, please. For about 8 more minutes.